All right, part 2 for 2.4. To make this easier for you guys, I'm not sure how well you can see the color scheme on this video, but I'm going to make the leftmost piecewise function blue, the middle black, and then the rightmost red, just to kind of distinguish between where one part of the piecewise ends and the next one begins. So when you think about f of x equals negative 3, f of x equals negative 3 is a constant linear function. From your Algebra 1 days, it was basically a horizontal line at negative 3. So you have to think about this as starting at negative 3, okay, because that's where my function ends. I have an open circle because it says less than. It doesn't say less than or equal to. And then every x value that's smaller than negative 3 yields the y value negative 3. So it's going to be all of this. And it's going to keep going forever. I'm not going right of negative 3 because it doesn't exist to the right of negative 3. Okay, hopefully that made sense. Now, the black is going to be our middle function here. It's also linear, but it's got better structure. Y equals mx plus b. All right, this means that it has a starting point at negative 2 on the y-axis. And then to plot more points, you go up 1, right 3. So I can go up 1, right 1, 2, 3, plot a new point. And pretty much my x is now 3. It's done. I can go down 1 and left 3. Because it's an equal to, I can fill in that point. And then I'm going to connect these dots. It's a closed circle here because it's closed there. And I should probably also say that the rise over run is 1/3 here, just to kind of keep things complete. Okay, so I got my blue section. It's a constant value at negative 3. My black section, it's got to be in between negative 3 and 3. It's right there in the middle. And then the red section is going to be this. 2 times x minus 3 squared minus 1. This is going to be a parabola. Whose vertex is shifted right 3, down 1. So right 3, down 1. It's an open circle because it's just greater than. But technically it's already filled in because the black function exists right there. So how do we graph a parabola that's kind of been cut in half? Our vertex is right here. All right? So what do we usually do with the vertex? Well, we usually say, plot a few points to the left and to the right. Now all we got to do is plot a few points to the right because it doesn't even exist left of 3. So the vertex is 3, negative 1. We've plotted that point. If I plug in 4, I'm going to get a y value of positive 1. If I plug in 5, I'm going to get a y value of 7. 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. All right, so it's a stretched parabola, narrower. That has this curve pattern. And that's it. There's number 1. It's a piecewise defined function that has a constant linear value and then has another linear value that has a nice little rise or run and then a parabola. right, this next one is a little bit more complex. It looks like it's got a lot of square roots going on. I'm going to do the same thing. I'm going to call this one blue, the one on the right red, and then black in the middle. So the blue square root function is f of x equals root negative x minus 2. So here's a trick that you have to use when you graph square root functions. In order to correctly identify the horizontal shift inside the root, if there's a negative in front of the x, I actually have to factor that negative out to get the... Struggling to talk right now. I have to factor the negative out to clearly see the horizontal shift. When I take a negative out of both negative x and negative 2, I get x plus 2. This would indicate a shift 2 units left. And the negative inside the root means it's shifted, not shifted, but reflected horizontally. So it's going to go this way now. So when I plot my first couple points, negative 1 would not be appropriate because negative 1 would create a negative inside the root. I got to plug in negative 3. Negative 3 plus 2 is negative 1. Make that negative. It's going to be positive 1. And then I could plot the next perfect square, 1, 2, 3, 4. From the start, it's going to go up to 2 here. Again, you guys could plot a bunch of points by plugging into the calculator. By all means, do that to check. Just make sure you understand how this structure works. Okay, blue is done. This actually looks kind of complicated. I'm going to go to the red right away because I can see instantly that the red is going to have a shift right 2 units, and it's just a normal square root function from there. So right 2 units, and it's basically going to mirror the blue here. So as the blue continues to go to the left, the red's going to continue to go all the way to the right, never ending, continuing to go to the right forever. So somebody's got to hold the middle together. So this one was right 2. This one was left 2. Reflected horizontally. And then here's my middle section. Now I haven't talked about this since I think the very first section of this chapter on graphing. Do you guys know what that is? That's a semicircle. It's a half circle that exists above the x-axis because it's positive. The 4 right there is the radius squared, so it's got a radius of 2. And then it's centered around 0, 0. It's centered around the origin because there isn't a bunch of stuff happening with this x. Remember, it was x minus h squared plus y minus k squared equals r squared to get a circle's standard form. This is going to be, look, this is going to be center 0, 0. 2 units out, 2 units up, 2 units right. And then you take away the centerpiece because it's not really a part of the circle itself. And there's our function. All right, let's check out one more. I made this not extremely complicated, but just more complicated than the last couple. So here's our blue. What does the graph y equals negative x look like? Well, it's y equals negative 1x, which is the same as negative 1 over 1, which is the same as negative 1 over 1x plus 0, which tells us what our starting point should be. That line starts at 0, 0. It goes down 1, right 1, or up 1, left 1. Now, since it's everything less than x equals negative 3, what you got to do is you got to go over to x equals negative 1, 2, 3, find your point, and then say only the ones left of or less than negative 3 count. So these guys, they don't count. And it's an open circle here. And it goes forever in that direction. The middle black is a cubed function. That's different. But we've seen it before. We saw it, I think, last Friday. All right, so this would indicate a shift. It's got that same type of vertex form that we saw with parabolas. It's shifted left 2, up 3. So left 1, 2, up 1, 2, 3. And this would be kind of like the centerpiece of things. Actually, you know what? I think I intended this to be a 2. Yeah, I'm almost positive I intended it to be a 2. So I'll try to go back and change that on the note sheet that I already attached to Google Classroom. What? Sorry about that. So it's left 2, up 2. And then you got to ask yourself, what does that negative out front do to it? Well, it reflects it vertically. So instead of your cubed function moving from the bottom up like this, it's going to start up here and then move down there. So we're going from negative 3 to 3. So if you want to, just plug in negative 3. Negative 3 plus 2, negative 1. To the third power, still negative 1. Make it negative, positive 1, and then plus 2 is 3. So negative 3, 3 is a point on that function. Now, plugging in negative 1 is going to yield the exact same value, except this is going to be positive inside here, which makes it negative 1 plus 2. Right? And then if we plug in 0, 0 is going to make it negative 8 plus 2, which is negative 6. All right, and based on that right there, I think I also wanted to change this to negative 6. I wanted to make all my piecewise connect. I just made a little mistake when I wrote the notes. Please forgive me. So, what does a cubed function look like? Well, it follows this pattern. Remember, it's got symmetry around that origin point. Our origin point got shifted left 2 and up 2, so that's what we're left with. All right, last part, the red graph. F of x equals 1/4 x to the 4 minus 6, and that's everybody who's bigger than 0. So if you recall, this shifts the function down 6 units, and this 1/4 compresses the function by a factor of, well, dividing by 4. So we can just plot a few points to the right of that, and we should get something that looks kind of like a parabola, but just approaches infinity a whole lot quicker. So 0, -6 is our first point. If we plug 1 to the right, it's still going to be really close to the to that -6 value. It's going to be -5 3/4. If I plug in 2, though, we're jumping up rather quickly. 2 to the 4th power is 16, times a 4th is 4. 4 minus 6 is -2. And then when we plug in 3, 3 to the 4th power is 81. So 81 times a 4th is going to be 20.25. Minus 6, 14.25. It's way up there, and it's probably about double this. Maybe a little bit more. So what I'm going to do is say it's got that parabola type shape, and then it moves up really, really quick. So I would just say down 6, compressed, and then it looks kind of like a parabola. All right, guys, I'm going to get right to changing these notes so that the paper copy is accurate for you. And yeah, hopefully this shed the light on piecewise functions and you guys have enough info to get through that homework. Thanks for watching.